Hey there, and welcome to Chapter 3. We're going to be looking at quadratics. In this chapter, we're going to start with 3.1 on graphing quadratic functions. And so our objectives today will be to graph quadratic functions and be able to find and interpret the maxes and mins of the quadratic. And so our two standards that we're looking at, ASC 1, interpret the meanings of coefficients, factors, terms, expressions based on real-world context, and graph functions based on intercepts, increasing, decreasing, positive, negative, all terms that we talked about back in Chapter 2, relative maxes and mins, symmetries, and behavior. We won't talk about periodicity in this chapter. And I want you to note one thing in the standard real quick before we move on. Look at what the standard says here. It says that we'll graph simple cases by hand and use technology for complicated cases. A lot of the problems that we do in here are simple cases, and we're going to look at a lot of those today by hand, not by using technology. Again, when we have large numbers, we have large values, that's when we use the technology, but simple cases should be able to be done by hand. That's what the standard says. So let's take a look at some things that we should remember from Algebra 1. And so we start off with the standard form of a quadratic function. And so remember that the standard form is all three powers, going from quadratic to the linear term to the constant term, in order as we go y equals ax squared plus bx, not a comma there, bx plus c. And so one stipulation to this formula is that a cannot be 0, because if a is 0, then this whole term just goes away and we're down to a linear function. It's not quadratic anymore. And so, and remember that y, we could also replace that with f of x or something of x. Vertex form, remember that's going to be a form where we can see the vertex of the function. And this has to deal with transformations we did in Chapter 2. And so think about our parent function, right, that x squared. Well, if I shift it to the right a few times, I get this x minus h, right? And if I shift it to the left, it would be plus something. And then if I move it vertically up and down, it's going to be plus some constant out back, right? And so the vertex form of a quadratic goes right to those transformations we talked about in Unit 2. So f of x, or y, is equal to a, that's our dilation factor and also therefore reflections. So a times x minus h squared plus the k. And so again, if you go back to what we talked in Chapter 2, transformations are the key. And in this formula, remember that hk is the vertex. The intercept form of a quadratic function. So intercept form comes to our factored form. That's another name for this form, factored form. And the key is that it is factored into its two pieces, x minus p and x minus q. Again, we'll have an a out front that defines our, again, dilation factor or our reflection across the x-axis. And in this formula, the p and q are the roots. One last thing to remember, the shape of quadratic is called a parabola. Not parabola, parabola. All right, so example 1, graph the quadratic x squared plus 3x minus 1 by making a table of values. Now, a table of values is not the best way to make a quadratic function, but let's see how we get it from the table first. And so I'm going to start out with x's. I'm going to plug that x value into this function, and then I'm going to get y values out of that. And so I'm going to pick quite a few x values here. I'm going to go from -4, -2, 0, 2, and 4. And we might add a few other numbers to this. So as we plug in the -4 squared, that's 16, plus 3 times -4, that's -12, so that's going to give us a +4. Minus 1 gives us +3. And so -2 squared plus 3 times the -2 minus a 1, so that's 4, and minus 6 is going to be -2, and that's -3. Plug in 0, so 0 squared plus 3 times 0, all that's 0, so minus 1 gives us -1. 2 squared plus 3 times 2 minus 1. 4 plus 6 is 10, minus 1 is 9. And if we do 4 squared plus 3 times 4 minus the 1, so that's 16, plus 12 is 28, this gives us 27. So it's going to be off the top of my graph here. So let's plot the points that we have. Negative 4, 3 is here. Negative 2, negative 3 is down here. 0, negative 1, 2, 9, and then the next point's off the graph. This doesn't really look like a parabola yet. Well, part of the problem is that these values don't give us a clear look at where the axis of symmetry is. And so that's why a table is not always the best method. It'll give us some points, and yeah, we can see that this is going to come down like this and come back up like this, but it's not the best method. And so let's go on and look at example 2, dealing with the axis of symmetry, the y-intercept, and the vertex. And so we're going to consider this function. F of x is equal to 2 minus 4x plus x squared. We're going to find the y-intercept, the equation of the axis of symmetry, and the coordinate of the vertex. And so one thing I could do with this function is I can flip it around so that it's in standard form. And so if I'm trying to find these different pieces, a formula that we need to know is that the axis of symmetry in standard form is found when x is equal to the opposite of b over 2a. Now, if you remember from Algebra 1, the quadratic formula, this is part of the quadratic formula. And we'll talk more about that as we get to section 6 and do that again. But the axis of symmetry is found in this formula. So for this problem, remember that your a is in front of the x squared, your b is in front of the x, and your c is the constant, right? And so I'm going to get that x is equal to the opposite of negative 4 all over 2 times 1, because the number in front of this is a 1. And so we're going to get 4 times 2, which is 2. And so that's our axis of symmetry. We've found it. X equals 2, axis of symmetry. The next piece we're going to do is find the y-intercept. Well, remember that the y-intercept is when x is equal to 0. Well, to find that, so that's going to be doing f of 0, that's equal to 0 squared minus 4 times 0 plus the 2. So all of that is just equal to 2 because that's 0 and that's 0. And so the y-intercept is just found at the c value. Again, your c value is always the y-intercept of a quadratic. And finally, the x-coordinate of the vertex. Well, give you a little hint here. If I'm drawing a parabola, right, and I draw this parabola somewhere on the coordinate plane, my axis of symmetry is that line down the middle that we talked about, that line of symmetry we talked about in chapter 2. And if I've got a line going through here, this point is my vertex, right? And this is my axis of symmetry. The x-coordinate of the vertex will be whatever x value we found for the axis of symmetry. And so the x-coordinate of the vertex is 2. Now, let's talk about if I had to find the y-coordinate and find the whole order pair. Well, I'm going to take this x value and plug it back into my function to find the y-coordinate of the vertex. Now again, this problem didn't ask for that, but I'm going to go there. So I'm going to do f of 2, and that's equal to 2 squared minus 4 times 2 plus the 2. Adding all this together, we're going to get 4 minus 8 plus 2. And so f of 2 is equal to negative 2, which means that my vertex is at 2, negative 2. And so that would be the point of my vertex. All right. And so that's another way to get our information of quadratics and be able to start graphing it, because I'm going to plot this point. And then, like we talked about during enrichment the other day, that a value, that dilation value, is going to tell us how far I go right and how far I go up for my first step. And we'll talk about that more as we go along. Okay? And so again, I'm not going to focus on tables here because I want you to understand how do we graph the quadratic. And so we've used the information that we've gotten here, right? We found the vertex, we found the axis of symmetry, we've got the y-intercept. And so 2, negative 2 is here. Our y-intercept we said was positive 2. My axis of symmetry is coming through here at x equals 2. And so it means any point that is on the left has to be equidistant on the right. So this point is 2 units away, which means that this one is 2 units away. And so I start to get a shape here, right? And I could plug in another value. I could plug in f of 1 to my function, and that's plugging into x squared minus 4x plus 2. And so we're going to get 1 squared minus 4 times 1 plus the 2. So it gives me 1 minus 4 plus 2, which that's negative 3 plus 2 is negative 1. And so f of 1 equals negative 1. And so that point would be here. Well, it's 1 unit away from my axis of symmetry, so I'm going to flip to the other side of the axis of symmetry, and it's going to reflect to that side. And so now I start to get my U shape of my parabola. So example 3 here, we're going to talk about maximum and minimum values. And so consider that f of x is equal to negative 2x squared plus 2x plus the 3. And we're going to determine whether the function has a max or a min, and then state the max or min, and then give the domain and range. And so remember when we talked about transformations, right? This negative in front is a reflection across which axis? It's a reflection across the x. And so when we think about this, instead of my parabola naturally opening up like the parent function does, this is the parent function, f of x, well, let's not call it f, but we'll call it p of x for the parent, is equal to just x squared, right? If I've got that negative in front, it's going to reflect it across the x-axis and make it open down, right? So p of x is equal to negative x squared. And so it doesn't matter anything else happening here. The negative in front of the leading term, the leading coefficient, if that's negative, it's going to reflect us across. And so instead of opening up and having a nice little minimum down here, I have a maximum. All things that we've talked about in chapter 2, so don't be like, oh my God, I don't know what I'm doing. This was from chapter 2, y'all. Okay, so it now says determine whether it has a max or min. We know it has a what? Maximum, because the parabola opens where? It opens down. And then state the min or maximum value. Well, where does the min or max occur? It occurs at the what? The vertex. So I go back to the stuff we just talked about a moment ago. How do I find the vertex? Well, if we find the axis of symmetry first, right? So x equals the opposite of b over 2a. Well, the b is 2 over 2 times negative 2. And so that's going to give me negative 2 over negative 4, which is positive 1/2. And so I'm going to take that, f of 1/2 is equal to negative 2 times 1/2 squared plus 2x plus the 3. And so I'm going to get f of 1/2 is equal to negative 2 times 1/4, because that's squared, plus 2, don't forget we plugged the 1/2 in here as well, plus the 3. And so we're going to get that this is negative 1/2 plus 1 plus 3. And so f of 1/2 is equal to 4 minus 1/2. So f of 1/2 is at 3.5 or 3.5. And so that's going to give me a maximum of 3.5. And when we talk about the domain and the range of this function, the domain, remember we're talking about x for domain, the domain is all real numbers. Negative infinity to positive infinity, right? The range, remember that's our y values, well, it has a maximum of 3.5. So the y has to be less than or equal to that 3.5, and an interval that would be from negative infinity to positive 3.5, and that will be a bracket because I am equal to. All right, and so as we look at the next example here, we're going to look at this souvenir shop problem. A souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that 50 cents each will increase in the price if he sells 10 fewer coffee mugs. How much should the owner charge for each mug in order to maximize the monthly income from their sales? And what is the maximum monthly income the owner can expect to make from these mugs? And so with this problem, we've got to set up an equation. And so what's going to happen is it's going to actually be in intercept or factored form. And so here's what we know is, I have a student being completely random. We're going to look at how to maximize this function. And so y is going to be equal to, we start with 200 mugs, right? And so what are we doing? We're going to send 10 fewer. So we're going to minus 10x. And in our second piece, so this is based on the number of items, our second one is based on the cost. And so the cost starts at $6, and he predicts that he'll increase by 50 cents for each set of mugs that he increases by. And so what our x is the number of sets, the number of times or the number of sets increased, right? And so the y would be the revenue. So we're looking for the maximum, and when we're talking about the maximum, we're talking about where is the vertex of this function, and it's going to be a negative reflection. It's going to be reflected down because of this sign right here. A negative 10x times a 0.50x is going to give us a negative 5x squared, which means we do have a reflection in the x-axis. And so we're looking for where is this vertex. And so we could do one of a couple things. We can multiply this out to get it into standard form. And so that's what we're going to do. Y is equal to 200 times the 6, and so that's going to be 1200. 200 times 0.5x is going to give us 100x, negative 60x, and then this will give us negative 5x squared. And so combining like terms and moving this around, we get negative 5x squared plus 40x plus 1200. And now, this is not necessarily a complicated example, it's just that the numbers are a little bit larger. And so we can still figure out where this axis symmetry is. X is equal to the opposite of b over 2a. And so the opposite of b, so that gives us opposite of 40 over 2 times negative 5. And so it's going to give us negative 40 over negative 10, which is positive 4. And so that means, going back to our problem, is how much should the owner charge for each mug to maximize? Well, we got that x was 4, and 4 is the number of times we're going to increase, and so 4 times the 50 cents gives a $2 increase. And so that's the answer to the first question. And the second question is, what is the maximum monthly income the owner can expect to make from these mugs? And so we're going to take that 2 and plug it back into our function. And so y is equal to 200 minus 10 times the 2, and then 6 plus the 50 cents times the 2. And so we're going to get y is equal to 200 minus 20 times 6 plus 1. And so y is equal to 180 times 7. And 180 times 7, that's going to be 700, that's going to be 56, so 1260. And so the answer to the second question is, what's the maximum monthly income? Well, his maximum monthly income is $1,260. Max monthly income. And so that is what we're looking at with quadratics. And again, we could graph this, and that's what we're talking about here is the vertex of that point. But we could also go to our graphing calculators and get the same as well. So the word of the day is completely random, and y'all have a great day. Bye.